In this video, we're going to look a little bit more at interfaces and some of the details about implementing them. So what is an interface? It's a class-like construct that contains only constants and abstract methods. It's very similar to an abstract class, and we're going to talk about that in a little bit. Sometimes you can substitute one for the other. But the intent for an interface is to specify common behavior for objects. So in the examples we saw in the last video, the common behavior for all of those objects is that they would act like phones. Whether it was a computer or an actual phone, they were all going to act like phones. Some other examples that we're going to see coming up, we'll see one or two of these anyway, the comparable interface or the edible interface or the clonable interface. And we'll see some of those coming up. Some of the one of these is created, a couple of them are built into Java. So how do we define an interface? We just say public interface and we give it a name, and then we declare any constants, any abstract method signatures that we are going to require for those that implement the interface. So here's an example of an interface called edible. And the interface edible only requires one method, and that is called how to eat, and it returns a string. Okay, so the edible interface requires that any classes that implement that have a method called how to eat. So an interface is treated like a special class in Java. Each of them is compiled into a separate bytecode file, just like a regular class would be. Like an abstract class, we can't create an instance of an interface, so we can't say new iPhone, because remember our interface of iPhone, you can't actually make an object from it. But in most cases, you can use an interface more or less the same way that you use an abstract class. For example, we can use it as a data type for a variable. We used it as a data type to create a list in the last video. You can also use it for casting and so on. So you can't create an object from it, but you can still use its data type. So here is an example. We're going to use the edible interface to specify whether a particular object is edible. This is accomplished by letting the class for the object implement the interface. So here's some different classes. We have a fruit class. An orange is inheriting from fruit. Apple inherits from fruit. We also have a chicken class, and we have a tiger class. Okay, so as you see here, fruit implements edible. Therefore, since these inherit from fruit, they will also implement edible. Chicken inherits from animal, but it is also edible. And then we have a tiger class that also inherits from animal like chicken does, but we don't consider tigers to be edible. I mean, I guess technically they might be, but typically they are not. So in this case, tiger inherits from animal and doesn't implement anything. Chicken inherits from animal. So actually the correct term, it does inherit. So if you looked at the class definition, chicken extends animal and it implements interface. Implements edible. And let's see if we can see some examples of this. So here we go. We have the edible interface, which requires that a method of how to eat. And down here we have a class called test edible that creates some objects. So we have an abstract class animal. So for animal, it has a weight, a get weight, a set weight, and it has a string to make a sound. And chicken extends animal, so it inherits from animal and it implements edible. Okay, so because it implements edible, the chicken class must have a how to eat method, and it does. It extends animal, so it has to have a sound. A tiger extends animal, so it has to have a sound, but since it doesn't implement edible, it doesn't have a how to eat method. And fruit implements edible. Apple extends fruit, and orange extends fruit. So fruit would contain the implementation for how to eat. Or actually, Apple has it. Each of them have it individually. You could do that either way. All right, so there's a short example of those things. All data fields in an interface are public, final, and static. And all methods are public and abstract, so you don't have to use those keywords. I think in the example I did public, but I didn't use abstract. You don't have to use either one. So if you have a method called P, you could technically write it in your interface as just void P because it is automatically abstract and it is automatically public. Okay. Same thing for any constants that you have. So here we have an integer called K. It is static and final, meaning it's a shared constant. You don't have to write public, static, and final for those constants. You can just write int K. It is automatically, if it's in an interface, it is public, static, and final. The methods are automatically public and abstract. So you can leave those out.